It's lecture number 3. And today we'll talk about another method to find root based on what we can say fixed point iteration. What is this fixed point iteration? Now let's start to talk about this one in details. Okay, yeah. In fixed point iteration, we are dealing with something like this. This is the bin. Check the bin, it's working or not. Let's read this. Okay. Given a function f(x), where a is in x between a and b, that's mean closed domain. And I want to find root. If b or if x equals 0, I want to find the value of x. So idea in this method is a little bit strange, so excuse me with me. I will write here. First of all, I will rewrite f(x) as x equal gx. So first of all, I will rewrite f(x) in this form, x equal x gx 2. I will work on dx. So in this method, first of all, I have f(x), and this is in a closed domain. So this is the first condition. I have f(x) should be continuous. First, in a closed domain. The second condition. Third thing, I will write f(x) as x equal gx, or equal, for example, use x equal gx. Then I will work in this. What about f(x) forget? In fixed point, we will shift from function to another function. Repeat. First of all, conditions. Our function should be continuous. Second thing, in closed domain, so between a and b. Third thing, I will rewrite f(x) in this form, x equal gx. Then I will start to work in this function. Which function? Gx. What about f(x)? Forget this one. So gx will be x in x equal gx. So now let's start how we can find this gx. Okay, if we define gx in AB and gx or gb equal b for p equal to ab or belongs to ab, then the function just needs to have fixed point. Fixed point idea like this, I will show you. See, this is my function. This is gx equal x, and this is x. So I will rewrite again. This is gx. This is x. Cross between them at this point is root. you can find and at in our lecture, it's not in exam, how we can prove this method. Proof for this method you can find this one. Okay, how we can start practical example. Here we have another condition is called extensions of fx. If G is a continuous enclosed domain and belongs to AB, then function has a fixed point. Okay, this one explain. Skip this. This is just explanation. And this also I will come back to this one. And let's go to the directly exam. Here we have a condition. This one in red one. Uniqueness result. What is the uniqueness result? Okay, that means we have a result. We have answer. Let's read. Let G is belongs to closed domain AB and G is AB. This is continuous in closed domain and included A and B. For all x's, for all points. All points that means continuous. When we can say we have answer, if we have G prime exists, G prime in absolute value should equal to some value called K less 1 for whatever x. So first of all, I have fx. Second thing, I will convert to x equal gx. Then I'm working now with gx. Gx also has condition, continuous in closed domain, and another condition or another, for this one is g prime x in absolute value less or equal to k, and should be this k equals less than 1. This k should be less than 1. This k should be less than 1. Okay, now let's take this example to prove this one. Consider the quadratic function square x minus 1. And he will ask me now to solve based on fixed point. This is if x equal this. In fixed point, we will not use if x, we need to convert to gx equal x. So I need x outside. So in this method, we have many gx's. For example, I will select one for you. I will take this x to another part. So x equal square x minus 1. This is called g1x is square x minus 1. Correct? Yes. Second one, I will take x square x equal x minus, so it will be positive 1. Then x equal x positive 1 half. So now g2x is under root is plus 1. And we have many. So now have a good question. Which gx is correct? Which gx is not? In another form, all these gx's are acceptable for me. So for this reason, we start to make g prime x, and this is equal k, and k should be less than 1. We said this unique uniqueness result. Okay, let's continue this example to see how we can solve this one. This is the example. So I start with this gx. I made this one. In exam, I will give you gx. In exam, I will give you gx. So don't worry about this one. In exam, I will give you this gx now. What about fx? This forget now. You have to work with this. Don't solve for fx. Now we have gx. For gx, we have a condition. Gx should be continuous. As it's continuous, it's x positive 1/2. In a closed domain, is it to me, I guess, from 1 to 2, it's a check. Yeah, from 0 to 1. Inside, I will give you also the domain. Now, I will draw out, I will find g prime x. G prime x is half x positive 1 minus half, correct? Correct? Suqi Ahmad, correct? Where are the experience in math? Yes. Abu Saeed, how are you, Abu Saeed? Good morning. Now, he told me for all the and absolute, you have to take absolute value, and it's a check. I select, for example, x here, I will select x0. Exactly, give you the value. So, for example, it's equal j prime for 0 equal, in absolute value equal, half 0 positive 1/2. So it is half root. So less than 0, yes. So correct. In example, for example, he will give to you, or he will give to you two boundaries, for example, for first one and second one. So you have at that time to test for input for first limit and the last limit. We will have an example about this one, so don't worry about this one. So from first look, we can see the j prime x. That's okay. We have the uniqueness, so we have a result. After that, what we have to do? Geometric. I don't need geometric. I will make like this table. It's so easy table, not like the section by section method. In this one, I have starting point x0. So I have it. I will draw again. This is okay. It's not good. This is here iteration. Pn plus 1, and here absolute error. Start for iteration, for example, 1 starts from 1. I see starting from 1, then 0. Take 0 to what's here? 0 plus 1, it is 1. Error is new minus old. So here it is new minus old minus 0 equal 1. Then take this one, excuse me. What's here? Actually, not this one, not this one. Okay, I made a mistake. Take this one, what's here? For second iteration. And now we have this formula. So root 1 plus 1 is equal to root 2. So now we have root 2, find error. So here, see the answer here until question that he asked me. So first of all, this table is so easy table. So it's not hard. And in exam, excuse me, you must make a table. If you have normal question, you must. Answer without table, that's me wrong. Error here is absolute. In fixed point, in bisection method, it was relative. Relative in bisection. Error absolutely. Here, just bisection is relative. Others all absolute error. So excuse me, focus on this idea. In bisection, this is the only one. It's the only one that has relative error. Okay, the only one that has relative error. Other methods, we have also 3 or 4 methods. We don't have relative error. Just we have absolute error. So take care about this. Clear? Okay. Again, Khalid, how are you, Khalid? Arda again, تكرار. Abu Said, where are you? Are you sleepy? See now how we can working with the graph. Okay. See, this is about method. For example, this is the first time we are here. We are walking to the another function. See, second step, we are walking to another to x again. Then go up to the another limit. Then go here. Then go here. Then go here. Then go here. Then this is root. This is the root. So this is the root. So as you see, error every time starts to decrease. This here, error 1 from here to here. It's error 2, error 3 until. So in this case, we have for error 2 things. Error convergence or divergence. In Turkish, convergence that's mean yakın sama, divergence uzak sama. So if error start to be small that means k, as I told you, less than 1. That means we have, okay, it's not so clear. Go away. Okay, this. We have answer. If error k bigger than 1, that means we don't have answer. And this is the answer exam. So, okay, in my opinion, think about this one. I have k bigger than 1. See, make table and see the error. See error. If error is start to be small, that's mean correct. If it start to be big, right, we don't have answer. So again, this I said before, we have to make k is j prime. If also k is bigger than 1, so you can say there's no answer. Yeah, with that, make a table. Yeah, my advice too, if k got bigger than 1, so for first time should be say no answer, make a table, and your eyes on the error. If error start to be small, that means stop. If error start to be big, that mean no answer. Okay, continue. So that's this answer. If I want to apply g prime x here is which one? 1 over 2x positive 1, as I told you. So I guess g prime is 0, 3, it's less than 1. So we have answer. We have answer. Now, how many, for example, if I need, for example, 10 exponential minus 4, 1, 2, 3, 4, 5. Here, error until error 10 exponential minus 5. So after what? This is the answer. Okay, this is my error. Cancel this. We don't need this. We didn't use this. We are using just this. So this is 10 exponential minus 5. And this is the answer. Here we can write B12 is 1.61803. This is the answer. Thank you. Thank you, Allah. You are clever, yeah. Abdullah, who say Abdullah aren't you? Safe. Wallah, you are clever. You have 001 Ethereum as gift from me. Yeah, I know, Said. Okay. J prime x is for 0, it's 1. For this, it's 1 over cube x. It's in my. So here I have to check. I guess we start from x equal 1. So J prime x here, 1 over 1 equal 1. So he said less than, bigger than 1. So for first time we can say no answer. With that, okay, here it should be I said less than 1. But here key equal 1. What I have to do? Make table. Every time make a table. Every time. Let's see the table. This is the table and see this error. First or one was 1, 0, 5, 0, and 6, 0, 0, 6. So error start to be small, decrease. So it's converged to the answer. So we can say, see that's the answer. Error start to be small, so we have answer. So again, at every time, if k bigger or less or equal to 1, make a table. And after that, decide based on the error inside this table. Here G right is minus 0, 3, minus 1, 4, this one. We can create the table and see here, for example, 1, 2, 3, 4. After 12 iteration, we have the answer. So the first here answer is 161.802. The first time at 12, let's check here. Is 161.032. So a little bit different. Same thing here, but a little bit you can find here in different. Here 0, 0, 0, 37. Here is how much? 0, 0, 0, 0, 298. So a little bit different. Okay, this is the explanation about this one, fiction iteration, and we can prove this one. You shouldn't use this one. This is just explanation about this method proof for this one, and it's the code if you want to write this one. By the way, okay, let's start to make fixed point algorithms here in I'll refer to this online. Yeah, with which one? With ChatGPT. What about this? Do you prefer to make this? Yes, make Control V and write Python. Let's see if Python can solve it. And start. So here I'm using now ChatGPT directly to write Python. X equals 0, this I give to you. I in this range. X in u equal if X error, then absolute error as I told you. X in u minus X. If error less than tolerance, then return X in u and you can do this one. Let's test here if it's online compiler. Yes, Control A, Control V. It's run or not. We enter value 0. We need formula. We didn't write formula for this one. So you have first of all you have to write formula. Then we have to check if we can solve or not. So here again you can find Python with ChatGPT 2 for this one, about this one. So again here you have to enter n equal 1, pn. You have to enter p, gbn minus 1. If it's done tolerance, then n equal increase 1 and end of the procedure for this one. Now we have this equation and we want to solve this equation in new methods. Again, cube x plus 4x squared minus 10 equals 0 in this domain 1 and 2. So first of all, we have to convert from fx to gx. Okay, yeah. So here you can find, I will show you 1, 2, 3, 4, 5 gx's. Now we have the questions. All these gx's are acceptable? Absolutely not. Let's check. I will take the first one. Here, excuse me. This is here. This topic I will return back, but after I want to solve this question, same question. He gives to me here closed domain 1 to 2. So first of all, I want to write gx. First gx is this one. It's the first gx. In exam, I will give you, so don't worry about this one. G prime x is 1 minus 3x minus 2. I will check for 1 and 2. So it's minus 10 minus 27 is bigger than 1. So for first time, we can say no, there is no answer. With that, make a table. 1.80, see here, error is increasing. It was 2, then 7, then 4. So we can say here there is no answer because error is increasing. So again, what we did, first of all, we selected gx. I will give you an exam. Second thing, G prime for the two numbers, then I will give you starting point. Here I told you starting with 1.5. See the error, your eyes every time on the error, this one. Here error is increased, that's mean divergence, that's mean uzaktama, that's mean no answer. Another one. This gx, and let's check. Again, G prime for this dx, you have to calculate at your home. Minus 2, minus 3. So first time it's looks like there's no answer. Again, it's see here 0, 2, and here we have minus under root. We are working with natural number, so there is no answer. Third gx, this one, you have to calculate G prime x. This gx you have G prime x, and you have this for 1 and 2. So x for 1 it's 1.7, x for 2 it's minus 2, 1.2 with that bigger than 1. So should we stop? No, absolutely not. Start to make a table. So see error here 0, 2, 0, 1, 0, 0, 5 decrease. So okay, you can, for example, stop based on the question. For example, 10 exponential minus 2. So this is 0, 0. So you can stop at 6 and write b number, example 6 is this one. It's answer 1.3678. This is the third one. Okay, now fourth one. Okay, now let's go to G for X, same thing. G for X, G prime X, and C0, 1, 0, 15. So it seems like acceptable. See here, after 12 iteration, error is no error. And this is exact answer. Which one is B? Now, continue. Yes, continue. Last one, same thing. You have to calculate this a little bit complicated. You have to calculate 0 and 0 to 8. And after 3 iterations, we got no error. So here we all together we have seen that's mean. In exam, don't worry about GX. I will give you GX. You have to check the GX and make a G prime X and solve it to see if it's we have answer or not answer based on this one. Again, make a table every time. Your eyes on the error. Okay, who with me? Check the names. Who with me? Okay. For example, who? Mariam, Rami, Samit, Sila. Okay. For example, let's take Sila name. Sila asked me, Doctor, can we find how many iteration before starting? You know, in bisection we said we have a formula. For example, how many iteration? We have formula. This is let's remember. For example, error. For example, error here over log 2 10 like 2 10 2. I guess if it's correct. B minus A. To find how many iteration before starting. Here we have, but here a little bit hard. So I will turn back up and stop here. Here. Which slide? Slide 69. How many iteration? Okay, yeah, let's start. Here we have Pn minus P less or equal Kn1 minus Kbn B1 minus B0. In this way, it is really important for exam. So this is memorization, for example. Because you have something like this. Is correct or not? So take care about this question. Now, Pn minus B, what is this? What is K? What is B1? What is B0? What is N? N is the number that I want to find. This is N I want to find. What is this? What is this? 1, 2, 3, 4 parameter that we have to find. How we can find those? Okay, we have example. Consider the iteration function gx. So he gives to me directly gx equal 3 exponential minus over the interval third one. So this is A, this is B, this is gx. Starting with third, this is B0. Determine a lower bound for the number of iteration n required so that P minus B less than equal minus 5. Take expression minus 5. Okay, I will return to write formula. Pn minus B should be equal less than here K exponential n, I guess. 1 minus K. I will check B1 minus B0. Check if it's correct or not. Yeah. Here you have to use absolute value, so you can flip. Okay. Now let's check one by one. N I need. P in my B, so this is the error. So 10 exponential minus 5 equal K here is J prime X that we found before. So you have to calculate G prime. But Dr. G prime is a little bit hard. Yeah, I know. And this is the weak point in this one to find G prime. For example, G prime for 3 exponential minus X is 3 minus third logarithm 3. This is for X. I need for K, which K this is starting from third. So here G prime X, here X is third. So K here is this number. So it is 0, 7, 6, 2 exponential n over 1 minus 0, 7, 6, 2. Have we finished? Not yet. I need P1. P1 is G for P0. It's function. So I have to write this function 3 exponential B0 is B0 here equal third. So exponential third. Minus, I guess you have minus. See here. And this is the number. B0 is given, so you can calculate. I will rearrange again. I will write again for you. You can find here on the next slide. Here, see this one? Expand, yes. This is 10 exponential minus 5, 0, 6, 7, 2, 1 minus 7, 2, third minus this one. How we can solve this one? First of all, calculate this. Calculate this. Divide this over this, then you can get this number. 10 exponential minus 5. Then let's continue. 10 exponential minus 5 over this. 1.513. This 0.762 exponential n. Okay. Now with calculator you can use this, I guess. Okay, use this. Okay, here it is 10 exponential minus 5 over 1.513 equal this number. Okay, it's equal 0.66093 less than 0.762 exponential n. Now I want to take in, so I can take logarithm for both sides, correct? Can take ln for both sides. No, Mariam, is correct logarithm for both sides to cancel in. Yeah, I want to cancel this. I want to download this, so I can take logarithm for both sides and flip the one. So let's make logarithm for both sides. Okay, solve at your home, and you can find the answer, by the way. In this way, guys, it's your job at your home to solve this one. Okay, then you can determine how many iterations before starting. And here in our book is about 44 iterations to get this answer. Okay, if we open our book, just a minute. Is our book. This one. It's this one. It's in chapter number 1. Chapter, sorry, number 2. Here, we turn back. Let's see the question in your book. Here use algebraic manipulation show that each of the following functions has fixed point and he gives me fx and gx and asks me check. So this is fx. It doesn't mind for me. I have gx and I have to check this gx. Important question for me is this one. Which one? This one, for example, I have starting from, he didn't give me starting point. Perform the iteration if possible for each function. Define exercise 1. B0 is 1. B0 and 1. So you have to calculate G prime and start with B0 to find this one. Okay, yes. Another question here, this question 5. Use fixed point iteration method. This is the exam question model to determine a solution accurate. Here 10 exponential minus 2. So you have to make a table and check for this fx on 1 and 2 use b0 equal 1. So where is gx? In exam I will give you. Clear? In exam I will give you just to help you. Usually you have to find by yourself. Another question, use a fixed point iteration method to determine a solution accurate to within 10 exponential minus 5 for cube x minus 1 equals 0 on 1, 2, use b0 equal 1. Same thing. Here you have to find gx. In exam I will give you this question in exam. So usually about these questions, you have fx, but in exam I will give you fx, gx, a closed domain, and starting point. So your job is first of all to check gx. With that, make a table, set your eyes on error, and after that you can say there is answer or there is no answer. Any question about this? But excuse me, solve example at home.